A common question we hear when selecting industrial sensors is how do you choose between a 0 to 10 volt, plus or minus 10 volt, and 4 to 20 milliamp output? These are some of the most common analog signal formats used by industrial sensors, such as position, pressure, and temperature sensors, to transmit measurement data to control systems. With voltage output, the signal is represented as a voltage level relative to ground. With current output, the signal is represented as a current flowing through a loop. Each approach has its place depending on the application. Let's start with 0 to 10 volt output. This is a unipolar signal, meaning it starts at 0 volts and increases to a positive maximum. At 0% position, the output is 0 volts, and at full scale, it reaches 10 volts. Because of its simplicity, 0 to 10 volt output is widely used in industrial systems. It works well for short cable runs, typically 150 to 100 feet, and in environments where electrical noise is minimal. It's also easy to interface with many PLCs and data acquisition systems since 0 to 10 volt inputs are very common. Next is plus or minus 10 volt output. This is a bipolar signal, meaning it to represent both positive and negative values. 0 volts typically represents the midpoint of the measurement range, with negative voltage representing movement in one direction and positive voltage representing movement in the other. This makes plus or minus 10 volt signals especially useful in applications where direction matters, such as motion control, servo systems, and position feedback around a center point. However, it's important to understand that not all control systems support bipolar inputs. While plus or minus 10 volts is common in motion control and higher-end systems, many general-purpose PLC inputs are designed for unipolar signals like 0 to 10 volts or 4 to 20 milliamps. So when using a plus or minus 10 volt sensor, it's important to verify that your receiving system is compatible. Like other voltage signals, plus or minus 10 volt outputs share the same general limitations. Voltage signals are more susceptible to electrical noise and interference, and over longer cable runs, signal accuracy can degrade. Voltage drop in the wiring can also affect measurement. That's where 4 to 20 milliamp output comes in. Current output is generally the preferred choice for demanding industrial environments. It's ideal for long cable runs, hundreds or even thousands of feet, and for applications with high electrical noise, such as systems with motors, variable frequency drives, or heavy power equipment. Because the signal is based on current instead of voltage, it's much more resistant to noise, and it doesn't degrade over long distances. It's also less sensitive to voltage drops in the wiring. Another important advantage is fault detection. In a 4 to 20 milliamp system, 4 milliamps represents the minimum valid signal, and 20 milliamps represents the maximum. If the signal drops to 0, that typically indicates a broken wire, power loss, or another system fault. In summary, 0 to 10 volt output is a simple, widely supported option for short distance, low noise applications. Plus or minus 10 volt output adds the ability to measure direction around a center point, making it ideal for motion control and bidirectional measurements. But it requires a system that supports bipolar inputs. 4 to 20 milliamp output is the go-to solution for long distances, noisy environments, and applications where reliability and signal integrity are critical. Visit us at HGSInd.com to shop our full range of industrial measurement solutions. Thanks for watching. If you enjoyed this video, please subscribe and click the bell to turn on notifications so you never miss an update. For additional pressing and technical questions, visit us at HGSInd.com. Harold G. Shapus Industries, performance and reliability is our business. Thanks for being in our team.